Thank you for inviting me, joining today. What I want to talk about is something a little bit non-code related, but I want to try and change your thinking. So after this talk, hopefully you'll go home and say, okay, now before I start coding again, I want to take a different idea before I start writing more components, more modules, and just adding stuff to your application. So I've called this From Patterns to Implementation, because everything I try and do and think about nowadays is based off of design patterns. Before I learn something new, why was it built? What is the pattern that it's trying to teach me? And then you can go ahead and just implement that pattern. So that's the idea. You can hopefully follow me on Twitter. If you want to ask any questions afterwards, I like talking about anything Angular related, especially the architecture side. So feel free to ping me or follow me on there as well. Just grab one of these. So, this is the idea for today, the talk objective. I want to discuss something which we're going to call a system. So we're going to discuss the concepts of a system, what is a system, and the patterns of a system, what can we learn from them. Then we're going to discover different thinking for our code. So what can we take away by just thinking about something completely non-programming related? So, systems. What is a system? You can describe it as a set of things working together as parts of a mechanism or an interconnecting network, a complex whole. Now, there's systems everywhere. It could be my laptop, it could be a car engine, a car, a lorry, anything that you can kind of think of that's quite complex. There's lots of things that come together and work well together. And ideally, this is what our applications should do. They should have lots of small things. Individually, they should do the correct things the right way, and they shouldn't mess with each other. They should do one thing well, and join and make a complex whole. We also have a set of principles, procedures, according to which something is done, an organized scheme or method. So who here has some kind of style guide or something like this that they follow in their teams, or architecture, or it's not enough hands, we need more. So we need sets of principles. This is how it should be done. This is a path that I can then follow. So this is what I want to kind of bring out today, is thinking about something completely different. And I even used to work at places where managers don't really care about the code structure. They just want the project done. So hopefully you can show them this talk afterwards and say, we need to do it because look. So, why are systems important? We need responsibilities, we need separations of concerns. These are probably things that you've heard of already. We need predictability and consistency. One of the worst things in big projects is inconsistency, and everything is done completely different. So let's look at a perspective on systems. And the main focus for this talk is actually thinking about restaurants. We've all probably been to restaurants. You can think about your favorite restaurant and the worst restaurant that you ever went to, and compare the two as you're thinking about this. And as we do talk about this, I want you to kind of think about your applications at the same time. So don't just think about the restaurants, think about how you can apply this to modules, components, architecture, and these types of things. So in a real basic sense, a restaurant's made up of staff. It also has stock. We have lots of types of staff. We've got managers, waiters, waitresses, etc., etc. And we also have the food or the drinks. And those two are completely separate things. So while I talk about this, you can kind of think of the restaurant as a module, and you can try and think of the staff as some components. They all do different things. Now the stock could be your data layer. They're completely different things again. And the staff then interact with the stock, and they present it to customers who, in an application sense, are end users. So this is the idea. Bear with me. So staff, what are they responsible for? Customer communication. If you think about our components, they need to deal with customers, the end users, but they also need to deal with other components. So components, we have big trees of components. They also follow a process and responsibility, much like our components do. We test our components individually, and they are also responsible for presenting the stock choices. So when a new customer comes into a restaurant, they say, here is our menu, this is our stock. And when they load your application, here's the data that's available. It could be something as big as Facebook, there's lots of user-driven data, or it could be data that is for a smaller application internally, for example. So let's look at stock. Stock then defines the customer request. If you have a completely different menu, the customers can't order something that isn't on the menu. So this is kind of the data side of things. The stock is then managed by the staff, so the stock doesn't order itself, it doesn't just turn up, hopefully. And it's got to be, and these are quite important points, it must be well organized. It's got to be fast, it's got to be efficient. How many times have you sat waiting maybe an hour for a meal at a restaurant? Like, it gets, come on, where's my food? Where's my cheeseburgers? And it's got to be like that. It's got to be, because the users, as performance stats will tell you, they leave applications, they leave websites when things are slow. So we've got to think about this. Now, stock comes from third-party suppliers. Most of our applications, when we build them, someone else is using them. We're just giving them an interface to interact with. Now, the restaurant encapsulates all of this, so you can think of that as some kind of module. Manages the suppliers, so we have a supplier who has, like, for instance, lots of stock, and we want to send a request to them and say we need some more cheeseburgers and we need some more buns and these kind of things. Now, the restaurant also has decoration, so in here we've got lights, we've got tables, chairs, etc. And that's the same thing for a restaurant. That's the pretty side of the encapsulated module, if you like, in your app. And most importantly, we want customers to go there. There's no point building an application that's mildly okay. We want to impress our customers, so we want to make them go there. So let's look at breaking it down slightly further, some staff roles. So let's keep it simple. We'll just have some managers and some other staff. So a manager is responsible for the stock. We don't want other staff randomly ordering gallons and gallons of milk when they've already got gallons and gallons of milk and the fridge is overflowing with milk everywhere. So the manager should be responsible for the stock. He or she will order new stock, and when that stock arrives, they say, oh, employees, we have lots of stock, can you put it away where you need to? The kitchen staff will know this. So the waiters and the kitchen staff, they're not in charge of ordering the stock, but they might go and inform a manager and say, hey, we need some more of this, we need some more of that. And the managers then give them that information, such as the stock has now arrived. And you can kind of think about this as a smart and a dumb component, or a presentational and the containers, where we have a more intelligent component that's responsible for data, but our dumb components, our stateless components further down, they're not in charge of these things. We don't have random requests coming up way down in a component tree where they shouldn't really be. So ideally, a restaurant kind of works like this. We have a supplier, comes in, orders some stock. It then comes to the management staff. They say, yep, we need some more stock, or thank you for the delivery. And then this gets notified to our waiters and kitchen staff, and they say, yeah, we're going to put it away. And everything happens in that small system down below. If they run out of food or drinks, they go back to the management staff, who goes back to the supplier. And you can see that all the arrows go in a single direction. It's just one-way data flow, which we think about in our Angular apps. So the good thing about this is it's clear communication. It's easily extendable, which is one of the good things about building in a way like this. I think one of the common things people say is when you're building hierarchies of components is it tends to be a lot of inputs and outputs, and it might be a lot of inputs and outputs, but when you think of it in a different system like this, it kind of makes sense. So we have well-defined roles and processes, and you can easily test things like this in Angular applications. And we have lots of moving parts, and they all work well together, or hopefully work well together. Been hacked. There we go. So we have stock management. Let's take a look at this. So we have a process for ordering stock, and you can try and think about this as, I mentioned, a data. So this could be, for instance, our state management, or the application state. Now a manager would initiate a request, and they say, hey, supplier, we need some more food or drinks. So that's going to getting some data in an application world. It then alerts the supplier of the stock needed. This could be an automated email or a message request. The supplier then says, yes, we've confirmed that. The supplier then fulfills the stock order, sets everything up for delivery, and sends it to the restaurant. The manager then gets notified when a delivery arrives. And that sounds like a very sane and normal process. But it's not what we do a lot of times in Angular applications. We don't think about this very structured process. And this is where things like the Redux pattern with NGRX can help us think about this stock management, but for state management. So these are the ideas behind it. So this is 100% a Redux diagram, but I've flipped it in terms of a restaurant. So a manager sends a request, which is the order, which in a Redux sense is an action. It's then received, it's then processed, which would be a reducer in a Redux pattern. It's then processed by the supplier, and then it packages it up as some new stock, which would be new state in a Redux pattern, and it's then delivered back to the manager. Now that is one system, and I mentioned this one system approach. Now the manager obviously deals with another system. It deals with two systems. It deals with the state, and it deals with its child components or its other staff. Now again, we get the same benefits. We get clear communication, easily extendable, defined roles and processes, moving parts working well together. And that's the exact same list as what we looked at for the component side. So both approaches, think of them completely separate. And when you separate state and the component trees and modules and these things, they work really well, and you can test them all individually. So let's take our restaurant example. We've got the green dotted line. It's a module. Think about it as a module. Staff, all of the components in your module, and stock, you've got all your services and state management. Now, let's say that our application starts to grow. Following the same principles, the same processes, everything scales nicely. This is obviously theoretical. You've got to make that happen for yourselves. But theoretically, this will scale nicely. Now, let's say that a customer of yours, perhaps, wants more applications, or this restaurant does exceedingly well, and they start branching out, and they have more and more restaurants. If things were all over the place and uncontrolled, it's not really going to happen very, very tidily. Things are going to get messy. But if there's this system in place, everything's working nicely, everything has a process and a role, we can start to expand these with little issues, really. There's no reason why the restaurant in the middle acts differently than number 1 or number 3. So, application architecture. Let's think about more of our code-related things. So I'll just quickly mention that this does give us a scalable model. It's clear steps. We should have like coding guidelines or linters and these types of things where we follow patterns and design principles. So when, for instance, somebody new joins your team, you can say, okay, this is how we do things, rather than just lock them away and say, go and hide for a week, and then things end up being wrong. So we get no surprises. We don't get no process issues. If you imagine you had all the kitchen staff and maybe waiters, they just want to order new stock, and then they've completely ignored the manager and they've just gone to the supplier, the kitchen would be a mess, there would be food wasted, and these types of things. So this is kind of a good argument to think about a restaurant. We want to separate our concerns. We always try and do this. Think about the different types of components that we're building, and as well as bundling these up in particular modules. We define solid processes for the architecture, and that allows us to essentially do this nicely, so we can scale nicely. It's maintainable, it's efficient. Like we mentioned at the beginning, we don't want a restaurant to be very slow. We don't want customers waiting 2 hours for a simple meal. And growth is easy, and it's easy to review processes. So let's say, for example, everyone's got an application where there's just a bad piece of code somewhere. But with a structured approach, that bad piece of code is usually quite isolated. You can go and fix it and add that to-do comment, which probably won't get done. So without a supplier, or without a system, sorry, who is the stock supplier? Who is going to supply the stock? We might have multiple suppliers. You might have one who does the meat, one who does the drinks, but ideally you would find one single way to do this. So this is where something like the Redux pattern comes in. It's just a single way that we can manage state. If you've potentially used such as observable-driven services, you have different implementations. You might have, and you get issues with this with providers and lazy loading, etc., etc. So staff might order the stock without a system. I put commence to chaos. I'm sure you can imagine the worst case scenario with this. So money is spent, money is wasted, lots of time has been lost. You might lose time in a development team if you're moving code fast and shipping fast. We might have a challenge to scale. It's not a flexible approach. We don't get to refactor a big piece of the application. It might affect other pieces. And you can imagine all these different boxes and all the lines are crossing. We just want no lines are crossing. Each system should be independent, which leaves us with tightly coupled processes. We don't want this. So the bigger picture, it kind of looks like this. So there's two systems happening here. You can see that the manager kind of sits in the middle. He might send a request to the supplier, we get the order, receives, processed, it's packaged, the stock is then sent back to the supplier, sent back to the manager. And then we've got this other system, the component architecture system, and you can think of the other one as state. So in the component architecture system, where we've got waiters and kitchen staff, something real in your application is happening here. This is your component tree that the users are interacting with. So two completely different systems. Try and think about it this way, and the patterns that you come up with and design with will be far more beneficial. And when we flip this completely over from thinking about a restaurant to Angular, we have what we call a container component, which typically we dispatch in Redux. We dispatch an action to our store. It's then sent to a reducer. The reducer then gives us some new representation of state. And again, I did a workshop yesterday, and everything that is done here is step-by-step process, and everything is recorded. And if you imagine a restaurant sending a $20,000 delivery, they're probably going to have that recorded on paper. So customers received it, and it's been processed. Every step is logged. And we get this with state management, with Redux, and the really good dev tools. So once we've got new state, we get it back, sent back to the container component, and then the rest of it is up to you. It's stateless child components. We build these. We use things like async pipes, where we can essentially subscribe in our templates, pass just raw data down to these stateless child components. Now, one of the good things about using something like the async pipe in a parent component is we're essentially unwrapping the data. So our stateless child components, and the presentation I've called them here, essentially just deal with raw data. So they deal with an input which just could be an array. It could be an object. It doesn't care how it gets the data, which means if you decide that Redux might not be the best way for you, or you might want to roll your own observable way, then you can just swap out the right-hand side. You swap out that one system, and you've still got this whole component tree, which is predictable, it's tested, and it works perfectly. It doesn't care about the other system. So these are kind of my list of high-level things to think about before you dive into your next project. So the three things: modules, components, and state management. However you do state management is up to you. You can roll your own observable-driven approach, or you could use Redux, for example. So in a module, we typically have something like a root module, a feature module, and then we think about lazy modules, eagerly modules. And then we might end up with a share module or core modules that we dump stuff into, pretend it doesn't exist. We also have the components. So we have these containers, stateful components. We have the presentational and the stateless components. If some of these terms are new to you, just give them a quick read on Google, for example, and they'll kind of open your eyes to the design patterns behind them. Now the benefit, and I mentioned this earlier, is that all of the arrows flow in a single direction with both systems, state management and the component architecture. So everything is completely recorded, step by step, predictable. It's just one single circle. So one-way data flow, which we stole off of the React community, was a good invention. So with state management, we have this thing called a state tree where all of our state for our application lives. We have these things called reducers, which allow us to essentially create new state. And we also get the benefit of using this thing called an entity. So, for example, we could flatten a massive data structure to just look up things via object keys. So this is what we call an entity. You can check out the NGRX example application. They're using the entities, and there was NGRX/entities, which is a new package that they just released to help you deal with this even better. Now, selectors in NGRX, they're a complex beast, but they're one of the most powerful, and they essentially allow you to compose your state very, very easily. Kind of interesting to get your head around, but once you've got it, they work really, really well. And finally, the router state. So we have our application, but you probably, each time I inject the router, it feels a little bit weird for me. I don't really like doing it. So what we can do with Redux or NGRX, for example, is actually bind the router state to our store. So this state tree contains the exact state, the paths, the location, the query params of the router state. So we don't need to inject the router in components, and again, it's just freeing that state management side, the system, out of components again. So it cleans things up. When it comes to component architecture, this is what we essentially looked at. A manager was responsible for stock. It orders the new stock. It presents the new deliveries to the staff. Now, they're not in charge of the waiters and the kitchen staff, are not in charge of ordering stock, so just remember these for a moment. And they inform managers when they want something new. Much like we have an output, it informs the parent component. The manager then gives them new information. You might emit something with the event emitter, and you get something back via an input. And when we flick this over to component architecture, so these are basically exactly the same ideas, just two different concepts. Now a container component is aware of the store, and it dispatches actions. So you can think of an action in a container as the output decorator for a container. So when we want some new state, and we want to enter this state management system, we dispatch an action, much like we do here with an output. Now, a container reads data from the store, so you can take that as an input. And these concepts are exactly the same, but the components and the way that they get the data is slightly different. Now, with presentational components, they're completely not aware of the store. I mentioned this is a good approach if you want to perhaps swap out how you do state management. So they're not aware of the store, they don't care how they get their data, and you probably know that when you unwrap an observable, you just get the raw data, and you can just deal with things sensibly inside. Dealing with raw data tends to be easier than passing down things like observables and trying to subscribe to them in child components. It just gets a bit messy. So presentational, they invoke the callbacks, so we can access or create the bindings and send things back up to a parent. And we can also read data from the inputs. So those are pretty much exactly the same concepts. The way that we get the data in a container, we dispatch, we read. We use a selector, so we store.select, and we ask for a particular piece of data. Same with an input, that's how we get data. Dispatch is how we pass data out, and output is how we do it in a presentational. So ideally, this is and we looked at this exact diagram at the beginning, but for the restaurant. So this is the component version. So we have the store up here, container component. The container deals with the store, then the containers deals with that other system, the presentational components. So these are really good things to kind of think about and divide up before you get going on a project. Just draw some boxes on a whiteboard and say, how are we going to do our state? How are we going to do our modules? What do our modules look like? Because I find that I start lots of projects and it starts off really nicely and then it kind of just goes a bit south. So try and follow the patterns is the idea here. And here's a more visual representation of the previous slide, where we select from the store and then we pass it down as an input. If we want to dispatch from a child, we would use that output and then a dispatch. So the exact same thing is happening. You don't need to think of containers and presentational components as two monolithically different things. They're just different ways of getting data into a component and how we render. So state management, this is what we looked at. The manager initiates the supplier request. This is just a quick recap. It alerts the supplier of the stock that's needed. The supplier then confirms the receipt. We then get the stock. It then sends the stock, and then the manager gets notified. So that was that big diagram that we looked at, the Redux pattern. Now with state management, this is our chance to essentially jump out of the component architecture. We want to leave the component architecture tree behind at this point. So we would dispatch an action, and as I flick between these, they're identical the way that these happen. So this list in itself might be a good selling point for perhaps someone who is on the fence for using Redux, or at least trying the Redux pattern. So we dispatch actions for intent. Everything that we want to achieve is dispatched via an action. We get the benefits when we use NGRX store, where everything is done in an immutable way. So we get a massive performance boost with Angular just out of the box, and that's just a one-liner change detection on push in all of the components, so that's really nice. We also get to derive our state for the components with selectors. So selectors, I mentioned, they're complex, but they're really, really nice they're complex to kind of get your head around to begin with. They're kind of like how a database works, and you want to send some queries. So everything is testable, it's scalable, it's fast, and if you think about that in a restaurant term, everything should be smooth, it should operate nicely, and we shouldn't have any hiccups, and why isn't order number 17 arrived and it doesn't exist, perhaps? And with that, so here's how it looks all together. Components, dispatch, action, reducer, state, and that's pretty much the whole system. I've got some closing thoughts, which I kind of mentioned as we've gone through this. So no matter how you do it, these are just the ideas. Think about them as different systems. If you're potentially got a big component tree and you're mixing within a stateless component, you're then dealing with the store. Try and just draw the boxes of your component tree and then draw your store and then draw the lines to it, and you'll see that these cross over. And it might not be the best way to approach it. So abstract your logic. We think about these three different systems: modules, components, and then the state. Consider something like the Redux pattern, give it a go. And component trees are for consuming the state, not creating or injecting. Components are essentially just a big container that say, give me whatever data you have available. And we use the store to essentially power that. Abstracted state is easier to compose, it's easier to share, reuse, and test. We can inject state across modules, we can share it across components without worrying. So those are some of the good benefits that we get from using something like the Redux pattern as well. So hopefully you enjoyed that, and it's kind of nice to step back from just diving into code examples for once and just think a bit higher up of how we're actually developing these applications. So I think when you go and do the exercise maybe afterwards, draw on a whiteboard, 3 boxes, and just think about how you're developing and architecting. So thank you for listening. I had a good time here today, so thank you very much.